morning, students. Last class, we were discussing fault analysis of power system. Today, we'll discuss another topic of fault analysis, symmetrical components. Before going to the details of symmetrical component, first we recap the last class. We have discussed what is fault, what are the reasons for fault, then the types of fault like series fault, shunt fault, again symmetrical fault under the shunt fault, symmetrical fault, unsymmetrical fault, the difference between symmetrical fault, unsymmetrical fault, and then which fault is more severe. After that, the fault current limiting reactor, etc. Now today we'll discuss about the symmetrical component. So in power system, about 95% faults are the unsymmetrical in nature. 95% fault. Unsymmetrical in nature means like line to ground fault, line to line fault, line to ground fault, double line to ground fault. So all are under the unsymmetrical fault. 95% and 5% fault are the triple line fault or symmetrical fault. So to analyze the unsymmetrical fault or unbalanced fault, there is a mathematical tools which is called the symmetrical components. And why the symmetrical component come? From the Fortescue theorem. Fortescue theorem. In 1918, Fortescue theorem states that an unbalanced system of n-related phasor can be resolved into n-balanced system of phasor called symmetrical component. Means what? Any unbalanced phasor means the n phasor can be resolved into n number of balanced phasor. Here n number of balanced phasor means positive sequence component, negative sequence component, and zero sequence component. These all are the balance in nature. So I have written that for three-phase system, two are the balanced set of phasor and one are the co-phasor. Means all three are the balance, but under this balanced three phasor, two are the balanced phasor, positive and negative, and another one is the co-phasor. Co-phasor is the zero sequence phasor. So what are the positive, negative, and zero sequence? I will discuss in the next slide. And summation of these three equal to what? Unbalanced phasor. Unbalanced phasor means the voltage or current phasor. So here we can see that this is the unbalanced system phasor. Unbalanced system phasor. This unbalanced system phasor equal to what? Positive sequence phasor, negative sequence phasor, and zero sequence phasor. Positive sequence phasor means denoted by 1, A1, B1, C1. Same way negative sequence denoted by 2, A2, B2, C2, and zero sequence A0, B0, C0. Next, the three sequence component means the positive, negative, and zero sequence. What is the positive sequence? So here you see that positive sequence are here is the clockwise sequence, clockwise ABC, clockwise sequence, and the sequence is same as the original phasor. I mean, if there is an unbalanced fault or unbalanced phasor, whatever the balance, I mean, whatever the phase sequence, the same phase sequence for the positive sequence also. Magnitude all are same, equal in magnitude, and all phasor are 120 degree phase apart and the same rotation as original phasor, same rotation ABC, and this positive sequence present both before and after fault. Next, the negative sequence same as positive sequence, equal magnitude, equal phase difference means 120 degree phase difference, but the rotation is opposite. Here ACB, not ABC, ACB. And this negative sequence is present during unbalanced fault, whenever the unbalance is there, unbalanced fault condition. Next is the zero sequence. Zero sequence, here all the phasor magnitude are equal, but this all are the zero phase displacement, no 120 phase displacement. And this is present only when there is a ground involvement or ground fault, in case of ground fault. Next, unbalanced voltage equation. We know that this is the unbalanced system. Unbalanced system means the A unbalanced system of any, like the unbalanced system of phasor of either current or voltage phasor. A, B, and C. These three phasor are magnitude are not same, and the phase sequence also not same. Not phase sequence same, but I mean the phase displacements are not same. This is the unbalanced system. And this unbalanced system, this equation, the voltage equation of this unbalanced system is VA. Suppose VA, VB, and VC. These three are the unbalanced voltage phasor. Suppose this is the VA, VB, and VC. These three are the unbalanced voltage. These three VA equal to, we can write the summation of positive, negative, and zero sequence of the VA. VA1 is the positive sequence of VA phasor, negative sequence of VA phasor, zero sequence of VA phasor. Same way, this VB can be decomposed or can be resolved by VB1, VB2, VB0. Same way, VC equal to VC1, VC2, VC0. Means these are the unbalance. These are the unbalance. This unbalance can be analyzed by with the help of balance. Three set of balance. Understood? Next, the alpha operator or shift operator and the transformation between phase sequence component to phase component. First of all, what is alpha operator? Alpha operator, alpha equal to what? 1 at an angle 120 degree. Means a unit phasor that rotate any vector by 120 degree counterclockwise or anti-clockwise direction. Means what? Alpha is what? Alpha can shift any vector. Suppose the vector VA1, the alpha can shift this VA1 from here to here, anti-clockwise direction, 120 degree anti-clockwise direction, by multiply the alpha. Like suppose VCA1 phasor, VCA1, suppose for this phase sequence, for this phase sequence, VCA1 equal to, we can write alpha multiply of VA1. Means what? The alpha can shift VA1 from here to here by multiplying alpha. VCA1 equal to alpha into VA1, anti-clockwise direction, rotation, 120 degree. Same way, VBA1, how we can write VBA1 in term of VA1? VB1 means how we can reach VB1 in anti-clockwise direction. If we move 120 plus 120, 24, 240. 240 equal to 240 means alpha square equal to 241 at an angle 240 alpha square. So VB1 we can write alpha square means 120 degree anti-clockwise direction rotation into VA1. So alpha square VA1. Understood? Okay. Same way for negative sequence, negative phase sequence, how we can write VB2 in term of VA1. VB2 means from here to here, the rotation is how much? 120 degree anti-clockwise direction. Means VB2 equal to, we can write alpha VA2. Same way, VC2 equal to what? VC2 equal to, we have to move from here to here in 240 degrees. So we can write alpha square. Alpha square equal to what? Alpha square equal to 1 at an angle 240. Alpha equal to 1 at an angle 120 degree. And here the alpha equal to, also we can write minus 0.5 plus j 0.866, means from polar to rectangular conversion here. Alpha square equal to, again we can write like this. And alpha cube equal to what? 1 at an angle 360 or 1. The equal to, the value is 1. And these are the property of alpha shift operator. 1 plus alpha square equal to 0. In the phasor sum to 0. And so from this relation and this relation, from positive sequence and negative sequence, we can write, we normally know that the VA equal to VA0, VA1, VA2. And VB equal to, again we know that VB0, VB1, VB2. And this VB0 equal to also VA0, because VA0, VB0, VC0, all are the zero sequence. And all magnitude are same. So we can write VA0 equal to VB0 equal to VC0. So VB0 we can write VA0. Same, you can write like this. And VB1, this VB1 we can write in term of VA1 also. How? Because VB1 equal to what? From here we know that VB1 equal to alpha square VA1. So this VB1 we can write like this. alpha square VA1. Okay. And VB2 is what? From VB2 means from this negative sequence. VB2 equal to what? VB2 equal to here. VB2 equal to alpha square VA2. Sorry. Right. Hmm. So here, so VA0 and VB0 equal to same. Okay. VB1 equal to what? Alpha square VA1. How we can write? From here, positive sequence VB1 equal to what? Alpha square VA1. How we got this? Because VB1 here, VB1, this VB1 equal to what? 120 degree plus 120, 240 degree rotation in anticlockwise reaction means alpha square. Can this VB2 equal to what? VB2 equal to what? Alpha VA2. How we got this? VB2 equal to from here. VB2 equal to alpha VA2. Okay. So from this alpha operator we make the relation. Same way VC equal to what? VC0, VC1, VC2. Okay, and VC0 also equal to VA0 because all are the zero sequence component. Next VC1 equal to what? VC1 equal to here from here in term of VA1, alpha VA1. So we can write like this. VC1 equal to alpha VA1 and VCA2 we have to go the negative sequence phasor. VC2 equal to what? Alpha square VA2. So VC2 equal to alpha square VA2. So this unbalanced phasor equation we can write like this. From here, if we write this three equation in the matrix form, mean VABC equal to A matrix into V012 means the zero sequence, positive sequence, negative sequence. So we can write like this. The A matrix is how it look like this. Like this? Why? Because here you see that here 1, 1, 1, 1. Here what? 1 alpha square alpha. Here 1 alpha square. So this 1 alpha square alpha 1 alpha square we can write as a matrix A here. This one 1 1 1 1 alpha square alpha 1 alpha square. So the matrix A. So ultimately in the matrix one we can write VABC equal to what? This matrix A into VA0, VA1, VA2, or we can write like this ABC equal to A matrix A into B0, 1, 2. In this way you can write. So here VABC is the phase component and this one is the symmetrical component or sequence component. This is a relationship. Also we can write V in term of V0, 1, 2. How? So if you take the inverse of the matrix V0, 1, 2 equal to what? A inverse matrix A inverse into VABC. Like this. Means here only the changes is that V0, 1, VA0, A1, A2 equal to 1 by 3 into matrix A into ABC. Like this. Okay. Next. Here one example mean the numerical example is given here. So in this example, IA, IB, and IC value are given. IA means the phase current of A given, phase current of B given, and phase current of C given. So I equal to 100 at an angle 0 degree, IB equal to 110 at an angle minus 100 degree, IC equal to 115 at an angle 110 degree. So from this given data, IA, IB, IC, all this value are not same. Means this is the unsymmetrical, unbalanced fault, unsymmetrical. So from here, we have to find out the symmetrical component. How? We know the relation because already we derived the relation. So IA 0 equal to what? IA 0 equal to 1 by 3 of IA, IB, IC. So 1 by 3 IA, IB, IC. Here IA equal to 100 plus J0. How it is written? Because from 110 from polar to rectangular conversion, simply polar to rectangular conversion is used here. Same way IB value also 110 at an angle minus 100 degree from polar to rectangular conversion. So this value got again same way IC value, put the value of IC. So after solving this, IA 0 equal to what? 13.86 at an angle minus 0.37 degree. So this is the IA 0 value. So IB 0 and IC 0. This all value also will be same because positive sequence component equal to negative sequence equal to zero sequence. So all the value will be same. And sorry, zero sequence component of A, B, C equal to same. Zero sequence component of A, zero sequence component of B, and zero sequence component of C equal to 0. Next, the positive sequence component of A equal to what? IA1 equal to what? 1 by 3 into, simply put the formula. IA plus alpha IB plus alpha square IC. Next, put the value 1 by 3. IA value is given. Alpha equal to 1 at an angle 120 degree. And IB into IB value is here 100 minus 100. So minus 100 plus here why it is written 20 because minus 100 plus at a angle 120. So 120 means this angle become plus 20. So that's why it is written like this. Again same way it is written. So after solving this, uh, value equal to what? IA1 equal to 105.7 at an angle 3.19 degree. Okay, so IA1, this one, and IB1, how will you get the IB1? Just the magnitude part is same, just the by multiplying the alpha or alpha square, we'll get this. Because IB1 equal to what? Alpha into IA1, alpha square into IA1, so 3.19 degree plus what? Plus the angle is how much? Alpha square means 240 degree. So if you add the angle 240 degree with 3.19 degree, then it will become 243.19. Okay, and IC1 equal to magnitude part same, and just we have to add the angle 120 degree from where? From these two. Here 3.19 degree, 19 here 3.19 plus 120 means it will become 123.19 degree. So same way the negative sequence component also we can calculate. Next example here the VA, VB, VC value given, find the symmetrical component. So here VA equal to, this is the polar form, 180 degree at angle 0 degree, then VB, VC value given, polar to rectangular conversion here done. Then simply by using the formula same way, VA0 equal to 1 by 3 VA, VB, VC, then put the all value, then solve it. Same way here also VA1 and VA2. So in this way, if the phase value of current or voltage given, we can find out the symmetrical component, or if the symmetrical component value is given, component value are given, then we can find out the phase component. So I think up to this everything is clear. So that's all for today's class. So thank you.